Guys, we are now going to begin indicator 2. And indicator 2, as you can see, the learning target, I can find the GCF of two numbers up to 100. And I can find the LCM of any two numbers up to 12. Okay, so basically these two are very, very essential components for you to understand. The greatest common factor, which is GCF, is especially required when you are simplifying fractions. So that is just one of the real life situations that I wanted to give you. LCM, least common multiple, is essential when you have, for example, fractions with unlike denominators. Okay, so let's see what is the difference between the two. So if I'm saying greatest common factor is the key word over there, and a factor is basically the numbers, the two numbers that you are multiplying in order to get a product. So if I say 2 times 3 is equal to 6, as you can see over here, the 2 and the 3 are the factors that gave me 6. All right? And so greatest common factor is the largest number that divides equally into a set of numbers. And it will always be smaller than any of the numbers, so less than or the same number as the numbers that are in the set. So I'm going to show you what that means in a minute, but just remember, if I'm saying GCF, just think of the F, and that means it's going to be fewer. So the answer will be fewer with the F. Just remember, because we're talking about the factors, so it's going to be fewer or the same number than any of the numbers in the set. On the other hand, if I'm taking least common multiple, multiples are basically, it's the product. When I am multiplying two factors, I get a multiple. So if I say 2 times 3 is equal to 6, the 2 and the 3 are the factors, and then the 6 is the multiple. And LCM is the smallest number that is a product or the multiple of the numbers. And another thing, please remember the LCM part, because that means it's going to be, the answer is going to be more or the same number than any of the numbers in the set. So the LCM will always be a number larger than any of the numbers in the set. So these are the two things I wanted to put it side by side so that you could see the difference. The greatest common factor will always be less, because F for fewer and the factors, and LCM is going to be more than or larger with the M part. So just remember that to make that connection, so we don't do the steps the wrong way, because very often students perform the steps of LCM for GCF or GCF for LCM, and then the entire answer that they give to me is incorrect because they switch the two. So this is a really good way for you to remember. Okay, so let's go ahead and solve some examples, and I'm going to teach you multiple methods so you can pick which one suits you best. Okay, so let me go ahead and erase this part, since first let's talk about GCF. All right, so let's say I give you two numbers, 12 and 16, and I ask you to find the greatest common factor. So there are several ways to do this, and you have the factor method, you have the prime factorization method, and then I'm going to show you my personal favorite, which is going to go really fast. Especially like in an honors math and all, you're trying to, start thinking faster. So, but right now, when you're beginning, you are welcome to choose any method. However, try to later on pick methods which would work faster for you. Okay, so if I say 12 and 16, let's first do, one way to do this is the factor method. Okay, so in this, I'm going to try to find the factors of 12, and then I'll try to find the factors of 16. So remember what I said factor was. Factor is when you are multiplying two numbers, that gives me the product. So what times what gives me 12? Okay, so we're going to like list all the different things. So I am going to write down over here factors of 12 and factors of 16. Okay, now very often you tend to forget that you also have a factor which is like 1 times 12. So that's the one people start doing 2 times 6 or things like that, and they forget the 1 times a number gives you the number also. So if I say 1 times 12, that's going to give me 12. All right, then I can say 2 times 6 is going to give me 12. And then if I say 3 times 4, that also gives me 12. And then, yeah, if I say 4, the 4 times 3, but then that's basically just a commutative property of multiplication, which can be flipped. Okay, so these are my factors of 12. Now let's find the factors of 16. The basic one, don't forget, 1 times 16, 2 times 8 also gives me 16. 3 times nothing is going to give me 16. So the next one I go 4 times 4 gives me 16. And that's the highest that we can go to. Those are the different factors of these two numbers. Once we have this, we are going to write out all the factors. So factors of 12, factors of 16. So let's find the factors of these two. And so here we had 1, 2, 3, 4, 6, and 12. So these are all the factors. 3, 4, 6, 12. So these are the factors of 12. And then let's go on to the factors of 16. And the factors of 16 are 1, 2, 4, and 4 again repeated. So we're just going to write it once. So we have 1, 2, 4, 8, and 16. So these are the factors of 16. Now, once I have this listed out, we are going to look at which one is the greatest common factor. So we have 1, but we have something greater than that, which is 2. This one doesn't have 3. Both of them have a greater, which is 4. And then we have nothing else, no other factors which are the same. Okay, so we're looking at the greatest common factor. So in this case, the greatest common factor is going to be 4, and that would be the answer for this one. So GCF is equal to 4. Okay, so this is the factor method. Remember what we said. The GCF will be fewer or the same number than any of the numbers in the set. So if I look at 12 and 16, you can see 4 is fewer than 12 and 4 is fewer than 16. So this is matching up, okay? All right, let me show you another method. And this is the prime factorization method. Okay, so this is the prime factorization method. Okay, now In this method, basically, we are going to find the factors which are in the prime number format. Okay, so let me go ahead and, well, I'll just use the same numbers then. Okay, so just let me go ahead and use 12 and 16 so that we can see how it doesn't matter which method I use, I will still get the same answer. Okay, so I'm going to take 12 and I am going to break it down to its prime factors. Okay, so 12, I can say any of those things besides 1 and 12 because 1's already, yeah, we're not using that. We're going to prime numbers, remember. So 2 times 6, okay? Please remember that 2 is the smallest even prime number. So I'm going to go ahead and circle that. 6 is a composite number. It's not a prime number. So I need to break this down further. So I'm going to say what times what? What are the factors that give me 6? So if I say 2 times 3, that's going to give me 6. And yes, this is a prime number. This is a prime number. So first I break down 12 into the prime numbers at the bottom. Then let me go to 16. And I can say 2 times 8. And it doesn't matter, even if I did 4 times 4, ultimately I will end up with the same prime numbers at the bottom. Okay, so this is the smallest prime, so 2 is already done, so I'm going to circle it. 8 is not a prime number, so I am going to go ahead and list the factors again. I can do 2 times 4. 2 is a prime number, 4 is a composite number. It's not a prime number, so I need to still break this further down, and I get 2 times 2, which is 4. So now I'm going to look at, okay, what are the common factors over here? We're going to look at what are the common factors over here. So both should have the same thing. So I have one of the 2's that are common, so I'll write 2. And then I have another 2 which is common. So I'm going to write times that other 2. And then I look at the numbers that I'm left with. I do not have a 3 over here, and I don't have 2 more 2's over here. So the only things common are this 2 and another 2. So we're going to write each of those once, because whatever is common we write once. And then 2 times 2 gives me 4. So my greatest common factor is 4. Doesn't matter if I do it this way or if I do it this way, you will still get the same answer. Now let me show you a method which is my personal favorite because it goes so fast. Okay? Let's see if I can just turn this a little bit so I don't have to erase. Okay. All right. So if I take 12 and 16, let's look at this here. All right. So my favorite method, you can, call it Miss Joshi's method. I don't care which method you call it, but this is or you can call it the upside down cake method, whatever suits you. So I have 12 and I have 16. Okay, so now what I'm going to do is I am going to see both of these numbers and I am going to try to divide them using the divisibility rules. So I know when I look at these two numbers, so I'm just going to put the division sign, okay, and based on divisibility rules, I know that both of these are even numbers. So because they are even numbers, they are both divisible by 2. So I'm going to write 2 over here. And I know that 12 divided by 2 is 6. and 16 divided by 2 is 8. Okay, so I get 6 and 8. Now both of these are still even numbers. That means they are still divisible by something, which would be 2 because they are even numbers. And I again make another layer of the cake, or whatever you want to call it. Okay, so here we go, 2. And 6 divided by 2 is 3. 8 divided by 2 is 4. Okay, now I see that I have nothing common with 3 and 4. Okay, 4 is not divisible by 3. 3 is not divisible by 4. So what I'm left with are these two numbers here. I'm going to look at this, and all I do, straight up, multiply these two, and my GCF is going to be 4. So this is straight up, really easy. You're just dividing by the common factors. You could have even taken 12 and 16 and straight up done because we know the rule for 4 anyways, the last 2 digits, but these are only comprised of 2 digits. So I could have just done straight up 4 over here, and I would have got 3 times 4 is 12, 4 times 4 is 16. My greatest common factor is 4. Okay, so 3 methods. Use any method that you find convenient. So these are the different methods. Okay, now one thing that I would really ask you to remember is sometimes you may be given a question. I'm going to erase this. Sometimes you may be given a question, what is the greatest common factor of 2 and 55? Okay, so if I'm given something like this, I know my divisibility rules. This is divisible by 2 because it's an even number. This is divisible by 5 because it is ending like, so 55 can be divisible by 5. It's divisible by 11. However, there is nothing common over here, but I'm trying to find the greatest common factor. So when nothing is common, please remember that the one thing common is 1. Because both are divisible. 1 times 2 gives me 2. 1 times 55 gives me 55. And so basically both are divisible by 1. And so in this case, when nothing is common to both of those numbers, then the greatest common factor will be 1 because they are still divisible by 1. Okay, so this is a tip I really wanted to give you because people do get confused on this one. Maybe there's nothing common. Well, there is. They're both still divisible by 1. Okay, now let's move on. So this is greatest common factor. Now we're going to move on to least common multiple. Remember that your answer is going to be more, the M part. So again, I'm going to show you different methods. However, you are free to choose which one is easy for you. So just like I had shown you a shortcut method over here, in which you're just dividing the two factors and then finding the common factors and multiplying them on the side. That is for GCF. I'm going to show you a really cool way to do LCM also. But let me introduce you to the different methods. Well, I should have just left this one because we are going to do the prime factorization method. I think this was 12. Let me just use the same numbers so that you can see the difference, okay? So this is the prime factorization method. And And we have a list method. So let me put that down also. That is a list method. And then I will show you the other method which I use also. Okay, so let's go on to least common multiple. And in this case, let's first start with the list method. Okay, the list method. So the list method is nothing but we are trying to find the multiples of 12. So remember we talked about what is a multiple? When I multiply two factors, I get a product or I get the multiple. So if I take 12 and then I have 16, so we are going to see what are the multiples of 12. Okay? So I know that 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60, and then so on. Okay, and so on. I don't think you can see. There you go. All right. Then for 16, I'm going to start the same way because I'm trying to go to the multiples. And I start with 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. And I'm going to stop there because I was trying to find the least common multiple. Okay, so that means I am going to look, okay, there's nothing common here, nothing common here, nothing common here. Then the least common multiple that I am finding is 48. So that's the least common multiple that I'm finding. So my LCM is 48 of 12 and 16. All right, so this was one way to do it. And then let's go ahead and do this method because we've already worked it out. So I just want to show this to you. So if I have 12 and 16, this is the prime factorization method. So again, you go down to the prime numbers. So now when I am actually doing the LCM part of this, all I need to do in this is to find the common factors first. And so we had done that. The common factor was 2. And then we had another common one, which is this 2. All right. So we have common written out only once. And then we also include the uncommon. So in this case, I have 2 and 2 over here, which haven't been repeated. So I am going to write that again. So we have this 2, we have this, so this 2 not repeated, and this 3, which is not repeated. So common ones written only once, and then we also write the uncommon ones that are there. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 3 is 48. So LCM is equal to 48. So it doesn't matter again, as you can see, you can do any method, you will still get the same answer. Now, my personal favorite again, because it goes quick and fast, I'm going to try to move this camera in this direction so you can see. Now, we are going to do something like this, but it's going to be downwards. Okay? It's going to be downwards. So if I say 12 and I say 16, we're trying to find the LCM now, not the GCF. Okay? So we are going to do the upside down division. Okay? So now once again, These two are both even numbers. So because they are both even numbers, they are both divisible by 2. So I'm going to write 2 over here. And 6 times 2 gives me 12. 8 times 2 gives me 16. So 12 divided by 2 is 6. 16 divided by 2 is 8. Now, since these are, so basically you're doing the same steps but upside down. Okay. Now let's see, because they are both still even numbers. So therefore, they are both divisible by 2. I am going to divide by 2 again. And I get 3 and I get 4, because 6 divided by 2 is 3, 8 divided by 2 is 4. Now, just like in the previous stage, now there's nothing common. There's nothing common. So what I'm going to do is, let me grab this red marker. And just to make it easy for you, so you remember that this is least common multiple, all right? And remember, the M means it's more than either of those numbers, or it's the same number. That's what LCM is. So I am going to take my marker and look what I'm doing. I am taking this up and I am making an L for LCM. Okay, so that you know exactly what you're supposed to do. And then I do 2 times 2, 4. Times 3 is 12, times 4 gives me 48. So see, same thing. And it's really simple, because I have just, taken the factors which are common and then the uncommon, make the L, so that you see we're talking about LCM. And so the LCM of 12 and 16 is equal to 48. And as you can see, we had said that the LCM needs to be greater than or the same number. So 48 is greater than 12, and 48 is greater than or more than 16. So it is filling the requirements. The only time when they're like, you're thinking, what do you mean by same as? Like, let's say I had 2 and 16 given to me. So then in that case, like 16 would have been my LCM. And so it is greater than 2, but it's the same number as 16. So that's what it basically means. Okay. So once again, try out those practice problems that I have put on my webpage for you to see the difference between greatest common factor and least common multiple. And once again, greatest common factor, talk about factors. So therefore, factors will be smaller than the product. So therefore, your answer, the greatest common factor, will either be less than or equal to one of the numbers. And you are welcome to use any of the methods I taught you, the factor method, the prime factorization method, or the upside down cake method. Okay? And then you have least common multiple, because we are talking about the multiples. So therefore, my answer is definitely going to be more than either of the factors or either of the numbers that are there for that matter. Okay, once again, so you can use any of the 3 methods that I taught you. The list method, the prime factorization method, or I made an L on the thing, so I don't know, you can call it Miss Joshi's method, whatever, but whatever works for you. These are the different methods. Do not confuse the two. And whenever you are in doubt, go look at that first part of the slideshow or this video recording, just to see the difference between the two. All right. Have a nice day, guys.